Hello students, welcome back to the fifth video of this playlist. So in this video, we will be solving question number 5 from the most recent past paper of uh, Statistics 1, which is the October 2024 S1 paper. So let's get started with question number 5 from the October 2024 S1 paper. So right at the beginning, in question number 5, you can see a histogram. We know that on the histogram, along the y-axis, it is frequency density, and along the x-axis, the quantity, it is what? Time. Okay, let's have a look on the, let's see what the question says. The histogram shows the number of hours. Okay, let me change the color. The number of hours worked in a given week by a group of 64 freelance photographers. Okay, so this histogram, it's showing the number of hours worked by 64 freelance what photographers. Okay, fine. So part A is asking here to give a reason to justify the use of a histogram to represent these data. Okay, so whether it is correct or it is what correct to use histogram to represent the number of hours. Is it correct or not? Okay, so let's see. We know that from the concept of histogram, we know that a histogram is basically used to represent what? Continuous data, right? So here they are showing what? The quantity here, it is what? The number of hours. Basically this is time. And we know that time is basically a what? Continuous what? Data. A continuous variable, you can say. So that means definitely, since time is continuous, so it is what? It's correct to use a histogram to represent the time in hours. Okay, so for part A we can say what? Time is continuous what? Continuous data or variable, whatever you say. Time is what? Continuous data. So a histogram is what? Suitable in this case. Okay, that's it. That's what part A has asked for. Fine. Okay. Next is part B. In part B, the question says, given that 16 of these freelance photographers spent between 10 and 20 hours working in this week. Okay. 16 of these, okay, photographers, 10 and 20. Okay. 10 and 20 means what? This, what? This rectangle, isn't it? This bar. Okay, so part B is asking to estimate the number that spent between 12 and 24 hours working in this week. 12 and 24 hours. Okay, so we know that in a histogram, the area of the birds is proportional to the frequency. In a histogram, what we know, the area of birds, area is proportional to what? Frequency, right? Okay, so if you take out the proportionality sign, then we need to have a constant, which is k times frequency. What is this k? This k is basically the what? Scale factor, the scaling along the y-axis, because here you can see that the frequency density, the scale for frequency density, it's not given, right? So our main work is to find out the scale along the y-axis. So to do that, we will use this bar. How many squares are there? What's the area of this bar? If you consider this bar, what's the area? The x-axis is what? 10, and 10 times 1 2 3, and then there is what? 3.2, you can say. So 1 2 3, and yeah, 3.2. Okay, 3.2, I meant what? 1 2, 3. So one small square is what? 0.2, right? So 3.2. So we can say here, we can consider for part B, the area. It's what? 10 times 3.2 times the frequency, the k, the scaling factor. This is equals to what? The area. This is what? 16, right? So what would be the value for k? The scale along the y-axis. The value for k would be 16 over 3.2. 32. 16 over 32. That is basically half, 0.5. Okay, that means along the y-axis, one square is what? 0.5. This is 1, this is 1.5, and this is what? 2, and so on. Okay. Okay, now we need to find out the area from 12 to what? 24. So let's consider 12. Where is 12? This is 10, this is 11, 12, this is 12. Okay, let me draw a dotted line that will let you understand better. This is 12. Okay, we need a line. Okay, here you go. 12 is basically there. Okay, 12 to what? 24. So where is 24? 24 is basically this. 5, 26, 27, 28. Okay, 24, 20, 21, 22, 23. 24 is basically there. Okay, this is 24. So we need the area between these two dotted vertical lines. Okay, so what it would be, let's have a look. From the width, consider the width. It's from 12 to 20. This is what? 8. 8 times what? This is 1.5. So one small square is how much? 0.1, right? So that means along the y-axis, the height of the bar is how much? 1.6, right? So number of what? Number of, okay, the estimated number. They wanted the estimated number. So the number is what? We got the width is 8 and the height is 1.6, right? And then what's next? From the next one is it's for 12 to 20. Now from 20 to 24. So from 20 to 24, the width is what? 4. And the height is how much? Height is 2. This is 2.5, 2.678. This is what? 2.8. Okay, so that means it would be what? Plus 4 times what? 2.8. So what would be the value? 8 times 1.6 plus 4 times 2.8. That would give you exactly 24. And that's the number of hours. So there is what? So the number is what? 24 hours. Okay, so 24 hours is the number of time that is spent by the freelance workers, freelance photographers, from 12 to 24 hours. That's it. Okay, it would not be 24 hours, rather it should be 24 peoples or 24 photographers. Okay, okay, it should be 24 photographers. We have to correct it out. So 24 photographers, because they wanted the number of peoples, right? Okay, so next is part C. In part C, the question is asking to find an estimate for the median time spent working in this week by these 64 freelance photographers. So median is what? Median is basically the data value that is half, that lies in the half of the what? Exactly half, which corresponds to half of the data, right? Half of the total data. So half of the total data is what? 32. 64, its half is what? 32. Okay, so we need to figure out at first the median class. Okay, so median class would be the class where the 32nd data value lies. Okay, so let's find it out using the cumulative frequency. From 0 to 10, the total area is what? 10 times half, which is what? 5. So 5 peoples are there. Frequency is 5. Okay, next is 10 to 20. From 10 to 20, how many, what's the area of this bar? 10 times the height is what? 1.6. So 1.6 times 10, that would give you 16. So 16 plus 5, it is what? 21. Okay, but we need 32nd, 32. Okay, next is from 20 to 25. Okay, from 20 to 25, what's the area of this bar? Height is 2.8 and the width is 5. So 5 times 2.8, that would give you 14. Okay, so 16 plus 5, it is 21, plus 14, it is what? 35. That means the 32nd term, it lies in this bar. Okay, that means this bar will be median bar or median class. Okay, so part C, median is the what? 64 over 2, which is 32nd data value, which lies in the class. Which class? This class is from 20 to 25. Yeah, exactly. In the class what? 20 to 25. Okay, so we got the median class. Now we will use what? Linear interpolation. Okay, using linear interpolation, look, linear interpolation. So there is a formula given in your textbook, a process basically for using linear interpolation, but I'll show you a more easier process to consider the interpolation method. This is basically Q2 equals to L plus N over 2 minus Fc into H over Fm. You don't need to write this formula in the exam hall. Okay, in the exam script, answer script, you can write, you can directly put the values. Okay, because this formula, it's basically derived from the what? Interpolation method. L is the lower limit of the median class, which is 20. Okay, plus N over 2. N over 2 is 64 over 2, which is 32, minus Fc. Fc is the cumulative frequency of the previous class to the median class. So the previous class is what? 10 to 20, right? So the cumulative frequency would be 16 plus 5, right? So which is 21. So 32 minus 21 into, that is times H. H is basically what? The width, the class width of the median class, which is 5 over Fm. Fm is the frequency of the median class, which we got here as 14. Okay, so that's the interpolation formula. You can use it directly. Okay, so what we will get here? 32 minus 21 times 5 over 14 plus 20. That is basically 23.928 something, that much. Okay, hours. Okay, time, median is basically the time. So Q2, it can be rounded to 23.9 hours. That is in 3 significant figures. So that's the median time for what? The median time is spent in the work by the 64 freelance photographers. Fine. Okay, next is part D. In part D, the question says Charlie decides to model these data using a normal distribution. Okay, fine. Charlie calculates an estimate of the mean to be 23.9 hours to 1 decimal place. So can you make a relationship? Look, in part C we got the median, this is 23.9, and Charlie, she uses normal distribution, and also she got what? Mean 23.9, right? Which is equal to the median. Okay, so part D is asking here to comment on Charlie's decision to use a normal distribution. Give a justification for your answer. Okay, so we need to what? Comment on Charlie's decision. So the decision depends on this fact, that the median of this data, it is equal to the mean of the data. So if median and mean are equal, then definitely it can be what? Modeled using normal distribution. No issues there, because for normal distribution, what? Median and the mean of the data should be what? Equal, right? And the data will follow, that's why it will follow a what? Symmetrical distribution, right? Since in the bell curve we can see that the mean, mode, median all lies at what? 0 for normal distribution, right? So for part D, what we can say, part D, we have to comment there, isn't it? So it's what? It's a correct decision. It's a correct decision. Okay, decision. So this is what? 1 mark. It's 2 marks. So this is for 1 mark. It's a correct decision. Since now the justification. Since the mean of the data is equal to what? To its median, right? And so it is what? Symmetrical distribution. Symmetrically distributed. And for symmetrically distributed, we know that bell curve, isn't it? Distributed. That's the justification. Okay, so that's the answer for part D, and that's the end of question number 5 from the October 2024 S1 paper. Fine.